In today's lesson, 7.2, Adding and Subtracting Rational Expressions, we'll be doing just that. We'll be adding and subtracting fractions, something that you probably remember from Algebra 1 or even middle school. But today we'll be focusing on simplifying with that. We'll start with like denominators and then go to needing to find the LCD. So hopefully what you remember back from middle school is if you have two fractions, you have to have a common denominator. So if we look at this first one, it works out very well because we have a common denominator, which is 9. And what happens is you go ahead and you just add your numerators together. So 7x plus y, you would simplify any like terms or cancel out any factoring that would occur. But in this case, that's all we can do. Nothing simplifies, and we just add the numerator. Notice I do not add the denominator. It simply combines, and you use what the LCD is. Now, in number 2, it's very similar, you'll see, except this time you'll notice that we have variables in the denominator. Nothing doesn't change with that. We'll still use the common denominator since this is the same. It just becomes your denominator, and you go ahead and you add the numerator up there. One thing that will change is once you do add that, you want to see if again it will factor or reduce. The denominator right here is factorable, and it becomes x plus 6 and x minus 3. And since our numerator is really x plus 6, you'll notice that that will indeed simplify. And since that reduces and cancels, you're left with 1 in the numerator over x minus 3. Unfortunately, not all rational expressions are that easy where they have the same denominator. So what you want to do is you need to find the LCD, the least common denominator. Now, to do this, we'll kind of look at a couple examples of pretend that these are, in fact, your denominators. Okay, so we'll put them in the denominator here. What you do to kind of find the LCD, again, the least common denominator, with longer polynomials is you will want to factor them. So I'm going to factor the first one, which happens to be a dots, and then I'm going to factor the second one, which is actually a PST, so I'll get m plus 4 and m plus 4. Now basically what you're going to do then is compare the two. You'll notice here I have m plus 4 and I have an m plus 4 here. But over here I have an m minus 4, but I don't have an m minus 4 over here. So what I'll be doing is I will be putting an m minus 4 to the other fraction. And over here, I'll notice that I have an m plus 4. Actually, I have 2 of them, but I only have 1 on the left. So I need to add in an m plus 4. That way, when I compare the two, I have 2 m plus 4s, and then I have 1 m minus 4. So this right here now is my LCD, all three of those binomials. Now the way that that's going to help us is once we get the LCD and we kind of put it into each fraction, that will help us to either add or subtract accordingly. So if we look at number 4 here, 2 over y minus 1 over y plus 4, they clearly have different denominators, but I can't factor them. So what I want to do is I want to put a y on this side because there's a y here. But to do that and not change the problem, I do y over y because that's 1. Multiplying by 1 won't change it. And I need to put a y plus 4 over on this side. So I multiply by y plus 4 over y plus 4. So now if I compare the two, you'll notice now they're exactly the same. So I will distribute the numerator for the first one, 2y plus 8. I'll keep my denominator. I'll have y in my second fraction, and then y times y plus 4. Now I have my LCD, so I'll combine like terms. Y times y plus 4. And then 2y minus y, we got to make sure you distribute that negative, will give me 1y, and then finally plus 8. Now you'll notice that nothing cancels, so we can leave it like this, or you could distribute the denominator. I would accept either answer would be fine. All right, if we take a look at number 5, we have 5 over r minus 2 minus r plus 3 over r minus 1. Again, what you're doing is you're comparing the denominators. These are not alike. Okay, this is a grouping together, and so is that, but they're not the same. So what I'll need to do is I'll need to put this r minus 2 to the right fraction. So I'm going to put r minus 2 over r minus 2, and then on the left I'll do r minus 1, r minus 1. And then you compare. Do I have exactly the same denominators in now each of my new fractions? Which we do. So in the left fraction, I'll have 5 times the quantity r minus 1, so we'll get 5r minus 5. I'm going to keep the two binomials as is, r minus 1 over r minus 2, minus, now since I have two binomials right here, we're going to FOIL that. That's going to be r squared minus 2r plus 3r minus 6 all over r minus 1, r minus 2. I'll combine that right away and get r squared plus 1r minus 6. Now again, like I mentioned in the last one, because that's a minus sign, we got to be aware of that. And what we're going to do is we're going to distribute it. Minus r squared minus r plus 6. So again, what we did is we took this minus sign and we distribute it to each one of the numerators. And then we'll be able to combine the fractions with my denominators. Combine my like terms, I'll get negative r squared plus 4r plus 1 over r minus 1, r minus 2. Now my numerator here actually does not factor, so that's actually as far as we can go with simplifying that one. Our last example right here is a little bit more complicated. We have 4 over p squared minus 6p plus 9 plus the quantity 1 over p squared plus 2p minus 15. Again, what I'm going to do is I'm going to just compare my denominators, and you'll notice they're not the same. So now what I'm going to do is I'm going to take this right here and I'm going to factor it. This is PST, which is p minus 3 and p minus 3. And then I'll do the other side. I will get p plus 5 and p minus 3. And then what I'll do is I'll compare. You'll notice they both have a p minus 3 right here and right here, so that worked out. But this one has a p plus 5, so I'm going to have to add a p plus 5 over here. Again, to the numerator and the denominator, so that takes care of that. But this one has a p minus 3, our second one, and I'll have to now add that over here. Again, I'm going to distribute my numerators, and I'll get 4p plus 20, and I'll get plus p minus 3. And my denominator this time will actually have 3 binomials. I'm going to combine my numerators, and I'll get 5p plus 17 all over p plus 5, p minus 3 squared. The numerator doesn't factor out or reduce, so that's going to be our final answer.